The Second World War was a crucible of aviation innovation. Propeller-driven fighters reached their peak performance. Yet, a new era was dawning with the advent of the jet engine. This technology promised speeds previously unimaginable. Germany's Messerschmitt Me-262 was the first operational jet fighter. It signaled the end of piston engine dominance in air combat. Though it arrived late in the war, its impact was profound. Allied pilots quickly understood the challenge posed by these swift new aircraft. The jet age had begun, and fighter design would never be the same. The lessons learned would shape the next generation of aerial warfare. First-generation jet fighters emerged in the late 1940s and early 1950s. These aircraft were pioneers, often built upon World War II airframe designs. They featured straight or moderately swept wings. Their engines were early, often unreliable turbojets. Speeds were typically subsonic or, at best, transonic. Avionics were rudimentary, consisting of basic radios and simple gun sights. Armament was primarily cannons or machine guns, a carryover from their propeller-driven ancestors. These jets were a significant step forward, but they also had limitations. They were faster than piston fighters, but not always more maneuverable at lower speeds. The focus was on achieving higher speeds and altitudes. The Korean War became the primary proving ground for these first-generation jets. The American F-86 Sabre and the Soviet MiG-15 became iconic adversaries. The Sabre, with its superior training and tactics, often held an edge. The MiG-15, however, had a better climb rate and higher service ceiling. These encounters highlighted the importance of pilot skill. They also drove rapid advancements in jet technology. Engineers worked to improve engine power and reliability. Aerodynamic designs were refined for better performance. The lessons from Korea directly influenced the development of the next generation of fighter aircraft. These early jets laid the critical groundwork for future air combat. Examples of first-generation fighters showcase this transitional period. The American Lockheed P-80 Shooting Star was one of the earliest US jets. The British Gloucester Meteor also saw service towards the end of World War II. The Republic of F-84 Thunderjet served extensively in Korea as a fighter bomber. These aircraft, while groundbreaking, lacked the sophisticated systems of later generations. Their primary role was air superiority, engaging enemy fighters. Some, like the F-84, also undertook ground attack missions. The first generation was about mastering the basics of jet-powered flight. It was about understanding this new realm of speed and the challenges it presented in combat. The mid-1950s ushered in the second generation of fighter aircraft. This era was defined by a singular pursuit: supersonic speed. Designers pushed the boundaries of aerodynamics and engine technology. Afterburners became common, providing massive thrust boosts for short periods. Aircraft designs featured sharply swept wings and a more streamlined appearance. The sound barrier was no longer an obstacle, but a routine performance benchmark. This generation aimed to fly faster and higher than ever before. The focus shifted from pure dogfighting maneuverability to high-speed interception. The Cold War rivalry fueled this rapid technological advancement, as East and West vied for air supremacy. A crucial development for second-generation fighters was the air-to-air missile. Early guided missiles like the AIM-9 Sidewinder and AIM-7 Sparrow began to appear. These weapons promised to engage enemy aircraft from beyond visual range. This led to a temporary de-emphasis on cannons in some designs. The theory was that future air combat would be dominated by missiles. Radars also became more common and more powerful. These early airborne radars helped pilots detect and track targets. They provided targeting information for the new missile systems. However, these early missiles and radars were often unreliable. They faced limitations in their engagement envelopes and susceptibility to countermeasures. Operational use of second-generation fighters revealed both promise and problems. Aircraft like the American F-100 Super Sabre, the first USAF fighter capable of sustained supersonic-level flight, were impressive. The Convair F-102 Delta Dagger and F-106 Delta Dart were dedicated interceptors. They were designed to stop Soviet bombers. The Soviet Union responded with aircraft like the MiG-19, their first supersonic fighter. The MiG-21 Fishbed became one of the most produced supersonic jets in history. These aircraft were incredibly fast, but often had limited range and maneuverability compared to their predecessors. The emphasis on speed and missiles sometimes came at the expense of traditional dogfighting capabilities. The technological advancements were significant. Engines became more powerful and efficient, though still fuel-hungry. Materials like titanium were introduced to handle high temperatures. Area rule, a design principle to reduce transonic drag, was implemented. This resulted in Coke bottle fuselage shapes on some aircraft. Despite the focus on missiles, many engagements still occurred at close range. This led to the reintroduction of cannons on later models, or a renewed appreciation for them. The second generation was a bold leap into the supersonic age. It laid the groundwork for the more balanced designs that would follow. It taught valuable lessons about the realities of air combat with new technologies. The third generation of fighter aircraft emerged in the 1960s. It continued into the 1970s. These aircraft were shaped by the experiences of the previous generation. Lessons from conflicts like the Vietnam War were particularly influential. Early reliance on missiles proved premature. Dogfights still happened, and cannons were still necessary. There was a renewed emphasis on maneuverability. Aircraft designers sought a better balance between speed, agility, and firepower. This generation also saw the rise of truly multi-role aircraft. These jets could perform both air-to-air combat and ground attack missions effectively. This versatility became a hallmark of third-generation designs. Technological advancements focused on improved avionics and weapons systems. Radars became more sophisticated, with better range and tracking capabilities. Look-down/shoot-down capabilities began to appear. Though still limited, this allowed fighters to engage targets flying below them against ground clutter. Air-to-air missiles became more reliable and capable. The development of guided air-to-ground munitions also expanded their roles. Aircraft like the McDonnell Douglas F-4 Phantom II exemplified this generation. It was a large, powerful, twin-engine fighter. It served with distinction in various air forces around the world. The F-4 could carry a massive payload of bombs, rockets, and missiles. The Vietnam War heavily influenced third-generation fighter development and tactics. Early versions of the F-4 Phantom lacked an internal cannon. This was based on the assumption that missiles would dominate. Combat experience quickly proved this wrong. Later, F-4 models incorporated a cannon. The war also highlighted the need for better air combat maneuvering training. Programs like the US Navy's Top Gun School were established. Aircraft like the MiG-21, though a second-generation design, saw extensive service. It was upgraded and remained a potent threat. The lessons from these aerial encounters drove improvements in fighter design, pilot training, and weapon systems. Other notable third-generation fighters included the Soviet MiG-23 Flogger. It featured variable sweep wings for optimized performance at different speeds. The French Dassault Mirage 3 was a successful delta-wing fighter. It was exported to many countries. These aircraft represented a maturation of jet fighter technology. They were more capable and versatile than their predecessors. They incorporated more powerful engines and refined aerodynamics. The focus was on creating aircraft that could adapt to various combat scenarios. The third generation set the stage for the highly agile and technologically advanced fighters that would follow. They were workhorses of air forces for decades. The fourth generation of fighter aircraft began to appear in the mid-1970s. It dominated air power through the end of the 20th century. These aircraft represented a significant leap in capability. They were designed with a strong emphasis on maneuverability and agility. Lessons from previous generations, particularly the Vietnam War, were key. The need for superior dogfighting performance was paramount. This led to designs with high thrust-to-weight ratios. Advanced aerodynamics, such as blended wing-body designs, became common. These fighters were built to outmaneuver their opponents in close-quarters combat. They also incorporated much more advanced technology. A defining feature of fourth-generation fighters was the introduction of fly-by-wire FBW flight control systems. FBW systems replaced traditional mechanical flight controls with an electronic interface. This allowed for inherently unstable but highly agile aircraft designs. Computers made constant adjustments to maintain controlled flight. This greatly enhanced maneuverability. Advanced avionics were another hallmark. Powerful pulse Doppler radars provided look-down/shoot-down capability. Heads-up displays, HUDs, projected critical flight and combat information onto the pilot's view. Hands-on throttle and stick (HOTAS) controls allowed pilots to manage systems without removing their hands from the controls. These innovations significantly reduced pilot workload. Key examples of fourth-generation fighters include the American F-14 Tomcat, F-15 Eagle, F-16 Fighting Falcon, and FA-18 Hornet. The F-15 Eagle was designed for air superiority. It boasted a powerful radar and impressive performance. The F-16 Fighting Falcon was a smaller, agile, multi-role fighter. It became one of the most widely produced and successful modern fighters. The Soviet Union responded with the equally formidable MiG-29 Fulcrum and Su-27 Flanker. These aircraft matched, or in some aspects, exceeded the performance of their Western counterparts. The Su-27 in particular was renowned for its exceptional maneuverability, famously demonstrated by the Cobra maneuver. These fighters were designed for a high-intensity conflict environment. They featured improved engines that were more powerful and reliable. Their weapon systems were more diverse and capable. They could carry a wide array of air-to-air and air-to-ground munitions. Many fourth-generation fighters were true multi-role platforms from the outset. They could seamlessly switch between air superiority and strike missions. Their long service lives are a testament to their effective designs. Many have been upgraded extensively over the years. They continue to form the backbone of numerous air forces around the world. The fourth generation truly mastered the art of conventional fighter design before the advent of stealth. Section 5. The enhanced fourth 4.5 generation fighters. As the Cold War ended, the pace of entirely new fighter designs slowed somewhat. However, technology continued to advance rapidly. This led to the emergence of what is often termed the 4.5 generation fighter. These aircraft are not a distinct clean break from the fourth generation. Instead, they represent significant upgrades to existing fourth generation designs. They also include new aircraft that incorporate technologies short of full fifth generation capabilities. This generation bridges the gap between the established digital fighters and the newer stealth aircraft. They offer enhanced performance and combat effectiveness without the full cost and complexity of fifth generation programs. Key features of 4.5 generation fighters include advanced avionics. Active Electronically Scanned Array, or AESA, radars are a prominent upgrade. ESA radars offer greater detection range, resistance to jamming, and the ability to track multiple targets simultaneously. They can also perform other functions like electronic warfare. Improved data links and network-centric capabilities enhance situational awareness. Pilots in these aircraft have a better understanding of the battlefield. They can share information more effectively with other friendly assets. Some designs also incorporate measures to reduce their radar cross-section, or RCS. This provides a degree of stealth, though not to the extent of true fifth-generation fighters. Examples of 4.5 generation fighters are numerous. The Eurofighter Typhoon, developed by a European consortium, is a highly agile multi-role fighter. It features advanced sensors and weapon systems. The Dassault Rafale from France is another versatile aircraft in this category. It boasts sophisticated sensor fusion and electronic warfare capabilities. Upgraded versions of existing fourth-generation fighters also fall into this classification. These include the F-15E Strike Eagle, F/A-18E/F Super Hornet, Su-30, and Su-35. These aircraft have received new radars, avionics, and weapon systems. These upgrades keep them relevant and highly capable on the modern battlefield. The operational significance of 4.5 generation fighters is substantial. They provide a cost-effective way for air forces to maintain a technological edge. They can counter most existing threats effectively. Their enhanced sensors and networking capabilities make them valuable assets in complex operational environments. While they may lack the all-aspect stealth of the fifth-generation aircraft, their reduced radar signatures still offer an advantage. They often feature supercruise capability, the ability to sustain supersonic flight without afterburners. This generation represents an intelligent evolution of proven designs. They incorporate cutting-edge technology to maximize combat effectiveness. They will continue to serve for many years alongside newer aircraft. Section 6. Stealth and Sensor Fusion, fifth-generation fighters. The fifth generation of fighter aircraft marks a revolutionary shift in air combat capabilities. The defining characteristic of these aircraft is all-aspect stealth. This means they are designed to be very difficult to detect by enemy radar, infrared sensors, and other detection methods. Stealth is achieved through a combination of airframe shaping, radar-absorbent materials, and careful design of all components. This includes internal weapons bays to avoid external stores that would increase radar signature. The goal is to allow these fighters to penetrate enemy airspace undetected. They can then engage targets before the enemy is even aware of their presence. This provides a decisive advantage. Beyond stealth, fifth-generation fighters feature extremely advanced avionics and sensor fusion. Multiple sensors, including AESA radars, electro-optical targeting systems or EOTs, and electronic warfare suites are integrated. The data from these sensors is fused by powerful onboard computers. This information is then presented to the pilot in an intuitive, integrated manner. This greatly enhances situational awareness. The pilot has a comprehensive view of the battlefield. This allows for quicker and more effective decision-making. Network-centric capabilities are also crucial. These fighters can share vast amounts of data with other aircraft, ground stations, and naval assets. They act as information nodes in the sky. The first operational fifth-generation fighter was the American Lockheed Martin F-22 Raptor. It was designed primarily for air superiority. Its combination of stealth, supercruise, and advanced sensors made it unmatched. The Lockheed Martin F-35 Lightning II is a multi-role fighter. It is designed for the United States Air Force, Navy, and Marine Corps, as well as allied nations. It emphasizes sensor fusion and network-centric operations. Other countries are also developing fifth-generation fighters. Russia's Sukhoi Su-57 Felon and China's Chengdu J-20 Mighty Dragon are notable examples. These aircraft aim to provide similar capabilities to their American counterparts. The development and procurement of fifth-generation fighters are complex and expensive. The advanced technologies involved require significant research and investment. However, the capabilities they offer are considered essential for maintaining air dominance in future conflicts. These aircraft are designed to operate in highly contested environments. They can counter advanced air defense systems. Their ability to gather and disseminate intelligence makes them valuable assets beyond just combat roles. The fifth generation represents the current pinnacle of fighter aircraft technology. They are shaping the future of air warfare. Their focus on information dominance is as important as their stealth and kinematic performance. Section 7. The Next Leap. Envisioning sixth-generation fighters. Even as fifth-generation fighters become more widespread, development is already underway for the sixth generation. These future aircraft are expected to enter service around the 2030s and 40s. They will build upon the foundations laid by their predecessors. They will also incorporate revolutionary new technologies. The specific features are still being defined. However, several key concepts are emerging from various national programs. These include programs like the United States Air Force's Next Generation Air Dominance, or NGAD. The United States Navy has its F/AXX program. European efforts include the Future Combat Air System, or FCAS, and the Global Combat Air Program, or GCAP. One of the most discussed features is optionally manned capability. This means the aircraft could fly with a pilot on board or operate as an unmanned combat aerial vehicle, or UCAV. Artificial intelligence, or AI, will play a crucial role. AI could assist the pilot, manage complex systems, or even control the aircraft autonomously. This could lead to aircraft capable of performing missions too dangerous for human pilots. Enhanced stealth will be essential, pushing beyond current capabilities. This will involve new materials and design techniques. Hypersonic or near-hypersonic speeds are also being explored. This would allow for rapid response and engagement over vast distances. Sixth-generation fighters are expected to operate as part of a system of systems. They will likely control swarms of unmanned loyal wingman drones. These drones could perform various tasks. They might conduct reconnaissance, electronic warfare, or even carry additional weapons. This networked approach will vastly expand the fighter's reach and capabilities. Directed energy weapons such as lasers are another potential feature. These could be used for defensive purposes, like shooting down incoming missiles. They might also have offensive applications. Advanced C-41 or command control communications, computers and intelligence capabilities will be paramount. These aircraft will be nodes in a vast information network. The challenges in developing sixth-generation fighters are immense. The technological hurdles are significant. The costs will likely be even higher than for fifth-generation aircraft. However, the potential payoff is a new level of air dominance. These aircraft will need adaptive engines capable of operating across a wide range of speeds and altitudes. They will require advanced thermal management to cope with the heat generated by high speeds and powerful systems. The human-machine interface will need to be incredibly sophisticated. It must allow a single pilot or an AI to manage an unprecedented amount of information and control multiple assets. The sixth generation promises another paradigm shift in air power. Section 8, Legacy of Innovation, the Continued Evolution of Air Power. The journey of fighter aircraft from the first jets to the concepts of the sixth generation is remarkable. It is a story of continuous innovation and adaptation, each generation built upon the successes and failures of the last. The initial challenge was simply mastering jet propulsion. Early fighters like the Me-262 and F-86 Sabre were basic by modern standards. Yet they represented a monumental leap over piston-engine aircraft. They pushed the boundaries of speed and altitude. The Korean War provided the first real test of jet versus jet combat. It highlighted the need for better engines, aerodynamics, and pilot training. These early experiences were crucial. Subsequent generations introduced transformative technologies. Second-generation fighters broke the sound barrier and brought air-to-air missiles into play. This changed the nature of air combat, though not as completely as initially thought. Third-generation aircraft like the F-4 Phantom II matured these technologies. They became more versatile, capable of both air superiority and ground attack. The focus shifted towards multi-role capabilities and improved avionics. The Vietnam War provided harsh lessons. It led to a renewed emphasis on maneuverability and the importance of cannons. These lessons directly shaped the development of the highly agile fourth-generation fighters. The fourth generation, with aircraft like the F-15, F-16 and Su-27, brought digital flight controls and powerful radars. These fighters dominated the skies for decades. They remain highly capable today. The 4.5 generation represents an enhancement of these proven designs. It incorporates technologies like AESA radars and some stealth features. Fifth-generation fighters, led by the F-22 and F-35, introduced true stealth and sensor fusion. These aircraft prioritize information dominance and survivability in highly contested environments. They represent the current state-of-the-art in fighter technology. Their ability to operate undetected and share information is a game-changer. Now we look towards the sixth generation. These future aircraft promise even greater leaps in capability. They may feature optional manning, AI integration, hypersonic speeds, and directed energy weapons. The evolution of fighter aircraft reflects the broader trends in military technology. It shows a relentless pursuit of superior performance, survivability, and situational awareness. Each new generation has provided air forces with enhanced tools to project power and protect national interests. The legacy of innovation continues. The skies of tomorrow will be patrolled by aircraft that are faster, smarter, and more interconnected than ever before. This evolution underscores the enduring importance of air power in modern warfare.